Hello students, as we have discussed about the gaseous state, its properties and the different gas law in the previous videos. So in this video, we are going to discuss about the liquid state, its properties. As on the basis of the intermolecular forces, the states of matter are gas, liquid, solid. In our day-to-day life, we come across the different examples of liquids like water, oil, juice, milk, soft drinks, vinegar. So let us discuss its general properties. Liquids have the following characteristic properties. Number 1, liquids have fixed volume but not have fixed shape. Because of this, it takes the shape of the container. Next point, liquids cannot be compressed much, as the gases can be much compressed, but the liquids cannot be compressed much. Liquids have moderate density. They have generally less denser than the solid, but they are more denser than the gases. Next point, liquids have a diffusion capacity. That means, like gases, liquids can also diffuse. Next, liquids do not fill their container completely. Next, liquids generally flow easily. As we can know that the liquids can flow like the gases can flow. Similarly, liquids also flow like water. So the important properties of the liquids, that is low compressibility, lack of rigidity, high density compared to gases. But there are some important properties of liquids that we need to discuss here. That is surface tension, vapor pressure and viscosity. So we will be discussing on these properties of liquid in detail. So first we'll start with the vapor pressure. If a liquid is placed in an open vessel, then the molecules escape into the atmosphere by the process of evaporation. But if the liquid is allowed to evaporate in a closed container, then the vapor remains in the container and it forms two zones, that is liquid zone and the vapor zone. As the vaporization increases, the number of vapors start to increase and the number of water molecules or the liquid start to decrease. That is, by increasing the temperature, we can see that the quantity of water decreases. But the number of molecules in the gaseous state, that is in the vapor state, is increasing. So we can say that the level of liquid decreases and the number of molecules in the vapor zone increases. The molecules which escape from the surface of the liquid, it get confined to a limited space above the liquid. These molecules move randomly in all direction. You can see the molecules move randomly in all the direction and they collide with one another and also with the walls of the container. Because of this, the vapors exert a pressure. That pressure is called as vapor pressure. As in the initial stages, only there will be a decrease in the liquid level because the process here which is taking place, that is called as evaporation, in which the liquid molecules are converted into the vapor state. So here the evaporation process is only taking place in the beginning, that is in the initial stages. So that's why the liquid level goes on decreases and the number of vapors will be increasing. But after some time it is seen that there is no change in the level of the liquid as well as no change in the number of molecule in the vapor zone, because here now another process begins, that is a condensation process. So condensation process, that is the vapors are condensed into the liquid. So in the initial stages, the rate of evaporation is more than the rate of condensation. So in that case we can see that the level of liquid is go on decreasing. But slowly what happened? The rate of condensation gradually increases. So the number of molecules in the gaseous state is decreases. So rate of the condensation gradually increases. That means here the molecules are coming down. That means from the vapors to it is converted into liquid. So finally a stage is reached when the rate of evaporation is equal to the rate of condensation. That means how much number of molecules get evaporated, the same number of molecule get condensed. So that means there is no change in the liquid zone, and as well as there is no change in the vapor zone. So we can say that when the molecules in the liquid phase continuously vaporizes and condenses in a closed container. So a stage where the rate of vaporization becomes equal to the rate of condensation, that stage is called as equilibrium stage. Very important point, what is equilibrium stage? When the rate of evaporation and rate of condensation will be equal, in that case we can say that a stage is reached which is called as equilibrium stage. Now how we can define the vapor pressure here? The vapor pressure is the pressure exerted by the vapor in equilibrium with its liquid state. So as here the vapors which is developed, that vapors will start to collide with each other and it start to collide with the container. So it exerts a pressure, that is called as a vapor pressure. In simple words, what is vapor pressure? It is a pressure exerted by vapors, that is called as vapor pressure. So that is particularly when we define this one, it is a pressure exerted by the vapor in equilibrium with its liquid state, that is in the equilibrium stage. So that pressure is called as vapor pressure. So we can say that in the equilibrium stage, the amount of liquid remains constant. This state is called as the dynamic equilibrium stage. When the liquid is heated in an open vessel, the liquid vaporizes from the surface. So how you define a boiling point for a liquid? That is, it is the temperature at which the vapor pressure of liquid equal to the external pressure. That is called as boiling point. So how you define boiling point? It is the temperature at which the vapor pressure of the liquid is equal to the external pressure is called as boiling point or the boiling temperature. So depending upon the external pressure, there are two types of boiling point. That is the normal boiling point, as well as there is another boiling point, that is standard boiling point. So the normal boiling point is the boiling temperature of a liquid at 1 atm pressure. As we have already discussed the definition for boiling point, that is a temperature at which the vapor pressure of liquid equal to external pressure. And if that external pressure is 1 atm pressure, then it is called as normal boiling point. And if that external pressure is 1 bar pressure, then it is called as standard boiling point. So how you define standard boiling point? Standard boiling point is the boiling temperature of a liquid at 1 bar. So what is the difference here? The external pressure is different here. That is, if it is 1 atm bar is the external pressure, then that boiling point is called as normal. And if it is 1 bar external pressure, then it is called as standard boiling point. So that is here the pressure is measured in terms of atm and here the pressure is measured in terms of bar. That is, the value of a normal boiling point will be different from the standard boiling point. So when you take the example of water, the normal boiling point is 99.9 degrees Celsius at 1 atm pressure, that is at 1 atmosphere pressure. That is usually will represent as 100 degrees Celsius. So you are familiar with this boiling point, 100 degrees Celsius of water. That is actually the normal boiling point. But what is the standard boiling point for water? That is 99.6 degrees Celsius. So there is a difference. You can see small differences is there because here the external pressure is 1 atm and here is 1 bar. So definitely the boiling point, both the boiling point are different. So why it different? Because here it is measured in terms of atm and 1 atm is equal to 1.013 bar. So definitely 1 atm is not equal to the bar. So that's why we can see that there is a variation in the values of the boiling point. That is 99.9 degrees Celsius for the case of normal boiling point and it is 99.6 for the case of standard boiling point. So this is all about vapor pressure. In detail, we'll be learning about the vapor pressure and its relation. That all we'll be discussing in the 12th standard. Next important property of liquid is surface tension. In our day-to-day life, we will come across the various interesting facts, just like why the bubbles are forming spherical shape, the drop of liquid is forming a spherical shape, and water striders can walk on the water. So what is because? That is of surface tension of water. So that we need to discuss here. What is the surface tension for liquids? So better understanding, consider a liquid which is taken in a container. So in the case of liquid, there are two types of molecules exist. That is molecule which is in the bulk, that is called as bulk molecule, and the molecule which is on the surface, that is called as surface molecules. So what is the difference in these? Because the molecules which is in the bulk is surrounded by the molecules, the other molecules. So there will be an attractive forces between these. So that means the molecule which is in the bulk is equally attracted from all the sides. But in the case of surface, there will be only a net inward force. That means when you consider here the bulk molecule, that is equally attracted from all the direction. That is, it is equally attracted by all sides of molecules. Therefore, the net pull on this molecule is equal to 0 because it is equally attracted by the molecules from all the side. But when you consider the molecule which is on the surface, because on the surface, when you take this example, here this molecule is only experience a downward attraction because the molecules are not above the surface in order to attract it. So it will experiences a downward pull, that net, it experience a net force. So we can say that these have only attractive force downward the molecules below it because there is no molecules above it. So this create an imbalance force at the surface. In other words, we can say that the liquids at the surface is under a tension due to the imbalanced forces. This effect is called as surface tension. So what we can say that the net force in the case of bulk molecule is 0, but the water molecule which is in the liquid, that is in the deep liquid, is pulled equally from all the side. But the molecules which is on the surface, it experiences a downward force, that is the net force is not zero here. So we can say that the molecules which is on the surface are under a tension because of the unbalanced force here. So how we define surface tension? It is defined as the force acting per unit length perpendicular to the line drawn on the surface of liquid. That means it is an inward force. So we can say this force is perpendicular to the line. Just make an imaginary draw a line on the surface of the liquid. So this force is actually acting perpendicular to the line drawn on the surface of the liquid. This is called as surface tension. Next property of liquid, that is viscosity. It is a common observation that certain liquids flow faster than the others. For example, water and honey. Tell me which one will flow faster and which one is slow? Definitely, the water is flow faster and the honey, the flow was slow. So such type of liquids in which the flow was slow is called as viscous liquid. So in compared to water, honey is more viscous and this property is called as viscosity. So how we define viscosity? Viscosity is the measure of resistance to flow which arises due to the internal friction between layers of fluid as they slip past one another while liquid flows. So in simple words, how we define viscosity? It is a measure of resistance to flow of a liquid and which arises due to the internal friction between the layers of fluid. That means the fluid have different layers. So there is an internal friction existing between these layers. Because of this, it resists the flow of that liquid. That is called as viscosity. Unit of viscosity is poise. When a liquid flows over a fixed surface, the layers of molecules in the immediate contact of the surface is stationary. So as I told you, in liquids there are certain layers. So the layer which is in contact with the surface, that is quite stationary, and the velocity of the upper layer increases as the distance of the layers from the fixed layer increases. So that means the upper layer will have the greater velocity, that is the flow. That means that layer will flow more. So the upper layer, its velocity is more, and the layer which is in contact with the surface is nearly stationary. So that type of flow is called as laminar flow. So the type of flow in which there is a regular gradation of velocity in passing from one another to another, from one layer to another, is called as laminar flow. That is the type of flow in which there is a regular gradation of velocity in passing from one layer to another is called as laminar law. As it is shown here, the liquid have certain layers. So the layer which is in contact with the surface, that layer is nearly stationary. So these layers are flowing in different velocity. So such type of a flow that is taking layer by layer is called as laminar flow. So this is what about we have discussed about viscosity. So this is all about this video. Have a nice day.